The last section talks about the division of decimals. So for multiplication of decimals, we ignore the decimal points and we multiply them like whole numbers. But in the final answer, we put the decimal point back. But in division, we do something different. So we don't ignore them. We actually move the decimal point in both numbers. So here's in part B, they ask for the standard procedure. So step 1, you're going to have to move the decimal point in both numbers and such that also the same number of places to the right until the divisor becomes a whole number. So I explained in class why we want the divisor to be a whole number, because it's much easier to ask how many times 21 goes into another number, and then how many times 0.21 goes into a number. So that's why we want this number to be a whole number. So after we move, so notice, so we focus on the divisor. See how many times we have to move the decimal point so we can turn this number into a whole number. And notice we have to do it 2 times. In order to keep the equivalence, we also have to move the divisor the same number of times. Again, why we have to move the same number of times? That is explained here down in part C. So we're going to talk about it in a second. And after the first step, we're going to start to do long division. So we're going to set up, again, after we move the decimal points, we are going to get 730 divided by 21. So long division again. So first 21 goes into 73 3 times, and division 21 times 3 gives us 63, and do subtraction, we have 10, and bring down 0. 21 goes into 100 4 times, and 21 times 4 is 84, and then we have 16 remainder. And now, because we want to get the answer to the hundreds place, so we're going to have to add a decimal point. Again, the second step tells us the decimal point is placed above the decimal point in the new dividend. So we're going to put the decimal point right about this number here is the new dividend. Originally it's 7.3, but after moving the decimal point, we got 730. But it looks like we don't have decimal point, but it's right at the end of the number. So we're going to put the decimal point in right above in the answer, above the new dividend. Now we can add a 0 and bring it down, so get 160, and that's going to give us 7 times. So we're going to 21 times 7, 147. And we do subtraction again, which gives us 13, and we add another 0, bring down, so that gives us 6, because 21 times 6 gives us 126. And the subtraction will give us 4 remainder. And notice if you how many times 21 goes into 40, and that's actually going to be 2 times. So because this digit is less than 5, we are not going to run up, so we're going to get 34.76. And now we're going to and so the step 3 is divide as we were dividing whole numbers, so kind of like long division for whole numbers. The only time we deal with decimal point is in the answer above the line, we line up the decimal point. So why in the first step, notice what we did here was to move the decimal point in both numbers the same number of times. Why do we do that? Why does this keep the answer the same? So here there are 2 explanations. We can either rewrite this division as a fraction, 7.3 divided by 0.21. And then we use equivalent fractions, a property of equivalent fractions. We can multiply both the numerator and denominator by 100. And so we get 730 and 21. And notice that by the property of fractions, these two must be equal, whether it's 7.3 divided by 0.21 or 730 divided by 21. So that's why we could turn a division of fractions, decimals, to division maybe possibly whole numbers. Actually, sometimes you cannot get rid of the decimal point in the numerator, but that's okay. We just want to make sure the divisor doesn't have a decimal. That way, we can ask how many times 21 goes into something. Much easier than how many times 2.1 goes into something. The second explanation is, so if you imagine both of these decimals as dollars, so we have $7.3 divided by $0.21. So how many $0.21 are contained in $7.3? What we can do is we can turn both decimals into cents. So $7.3 equal 730 cents by times 100, because $1 equals 100 cents, and turning $0.21 into 21 cents. And notice that $7.3 equals 730 cents. $0.21 equal 21 cents. And that means when we divide dollar by dollar, we should get the same answer as cents divided by cents.